this video, we're gonna prove to you that trapezoidal rule, where am I? Trapezoidal rule over here, alright, is a good way to plot your S, because you remember you're in your S domain. Anything within the left half plane is considered stable. Alright, your poles or zeros is within here is still stable. Okay. However, if you were to go into the Z domain, alright, you may not necessarily be stable. Okay, because in the Z domain, if you have some poles or zeros over here, alright, when you plot inside the Z domain, it may actually be here. Okay, so it's not within this system, because in the Z domain, your whatever poles and zeros should be within this place. Okay, you still remember within the unit circle of 1, minus 1, this is j, this is minus j, this is plus 1. Alright, within the unit circle of 1, if you still remember. So therefore, in this video, we are going to prove to you that for all the values in the left half, for all the poles or zero in the left half plane in the S domain, can be plotted inside the Z safety zone, okay, by using trapezoidal rule. Okay, for backward and forward loop, it is unable to fully fill into this Z domain. Alright, for the forward, for example, okay, for the forward rule, for example, if you were to plot the poles or zeros or whatever, you actually plot within this region. Okay, you're gonna plot within this region. Alright, so you may have some S that is within here, you may have some S that is outside of the unit circle 1. Alright, so this is very tough to predict which poles is considered viable to be used. Alright, so therefore this is a very important understanding, because by using trapezoidal rule, you are able to confirm that all the poles within the left half plane can be plotted inside this Z stability system. Because once you know that your S is stable already, you also know that your Z should be definitely stable. Alright, we don't want, like, for example, if your S is stable and then in the end in the Z domain is not stable, and then you're gonna go back to S domain and then you change things again. Alright, so it's very troublesome. So therefore the purpose of this video is actually to prove that trapezoidal rule is a good method, and such that all the poles or zeros in the left half plane can be plotted within this thing. Alright, so I've talked about so long, so let's just start off with it. So to start, I'll just start off with the forward loop. Alright, so in order to represent my Z, I'll just bring my T upwards. So I have ST is equals to Z minus 1. Okay, and then I'm gonna put my minus 1 to the other side, so I have ST plus 1 is equals to Z. Alright, so in the Z domain, this is the Z domain, and this is the S domain. Alright, I can easily prove to you that forward rule are unable to do something about things. Alright, but in the end, before I start, not in the end, I know what I'm talking. Before I start, you may wonder, what is this equation? Okay, what are all these equations? Okay, if you don't know what the hell all these equations come from, how does this represent your backward rule or trapezoidal rule? Alright, I'll just suggest that you watch this video and come back. L8v4. Okay, this is the point where you derive your stuff from here. Okay, so this is my purpose right now. Okay, so in order to start, let's just start off now. So for my S to be stable in my S domain, alright, everything over here it's stable, alright. But when I plot into the Z domain, which is this unit circle of 1, okay, I'm gonna start from here. You see, if you still remember, the origin over here is plotted over at this side. Alright, so along all this is all along this side. You see? Okay, I think you get what I mean. So therefore, if this side all over here is stable, this means when you plot all the S's, all the S or poles or zeros all over this side, if you plot over here from all the infinite system, alright, you'll have all these things plotted all over here. So you're gonna plot all your left hand side all inside this thing. Okay, so as you can see, is your Z stable or not? No, right? Your z for some of the poles or zeros, alright, can be stables within here, but for poles, some poles and zeros that is further away will be plotted all over here, which is not stable anymore. Okay, so therefore this is something that you need to really consider. Okay, and just an example lah. Okay, so if my period is equals to 1, okay, and then my s is equals to 2j, right, because I have a pole just at this point. Okay, so at this point this is actually 2, alright, because it's in the frequency domain, so therefore this is 2j. I think you get what I mean. This is the real, this line is the imaginary, this line is the real. Okay, if happened that you forgot. So in the imaginary it is all j's. Okay, so I have 2j plus 0 real number, you see, so therefore I just only have 2j. So if I were to plot it over here, what I have is 2j, s is equals to 2j, and t is equals to 1, so it just times 1. Alright, so 2j times 1 is just 2j, so 2j plus 1 is equals to z, you see. So over at this side, alright, your pole over here is somewhat still stable, marginally stable lah. Okay, then if you were to plot into the z domain, okay, you have something like this, right? Your 1 is over here, alright, and then 2j is upward all over here. Alright, so your poles will be plot over here already. So this is the results. So are you stable in the digital domain? No, you're totally not. Right? So maybe another example, although yeah, I have set the wrong question, but I didn't, never mind, I just do another question. So still same thing, t equals to 1, if my period is equals to 1, and my s is equals to, for example, minus 1 plus 2j, for example, or maybe minus 2 plus 2j, sorry. So I will have something over here. This is minus 2 and this is plus 2j. Okay, so if I were to just sub in into this equation over here, okay, I'll have minus 2 plus 2j plus 1 is equals to z. So this thing over here is your st lah. Okay, your t is equals to 1, your s is minus 2 plus 2j, which I show you. So s times t, which is equals to 1, so therefore you just, I think you get what I mean already. So therefore this is simply s times t, where t equals to 1, so it's just simply s only. Okay, so if I were to just do it up, I'll have minus 2 plus 1, because these are all real numbers, so I have minus 1 plus 2j is equals to z. Alright, so from here you can see that this is at minus 1, alright, and then plus 2j. You see, plus 2j. You see your poles is actually not within this circle. As you can see over here, your poles is stable, but if you were to plot into the z domain, this is not stable at all. Okay, so I hope that this is very clear. So we can say that for the forward loop, for all this left half plane, it will be all plotted when it is in the z domain. The forward loop will be all over here. Okay, so this is only for the case when you're talking about the forward rule, not forward loop. Why I keep saying forward loop? This is the forward Euler's forward rule. Okay, so for this case, this is not very good, right? So therefore, let's go on to the backward. So for the backward, it's slightly a little bit tricky. Okay, so in order to illustrate this, alright, I'll just rearrange this thing. Alright, z minus 1 over tz, I'll multiply by 1 over z divided by 1 over z. Okay, so this thing over here is equals to 1. Okay, so I'll just simply rearranging stuff. So I will have is z times 1 over z, I will have 1. And then minus 1 times 1 over z, I have minus 1 over z. Okay, and then this tz times 1 over z, I'll have t only, right? Because z and this 1 over z is cancel each other. Alright, so what I will have is that I would, okay, now I have this thing over here, okay, which is equals to your s lah. Alright, so I'll just bring it over here first. Alright, next I'll have 1 minus 1 over z is equals to st. Okay, because I bring this t outwards to this side. Okay, so I'll have this thing lah. Okay, or maybe I should have put it over here. Yeah, whatever thing that makes it nice. Okay, so this t over here, I just bring it out, I have this thing over here. Okay, so now in this such of the case, then what can I do? I just rearrange again. So what I have is st, give me a space, hold on. Okay, yeah, so let's continue. So I have this one, I'll just bring it over this side, so I'll have minus 1 over z, which is equals to st minus 1. Okay, and then I just multiply everything by minus. Okay, so what I will have is 1 over z is equals to minus st plus 1. Okay, I'm gonna switch sides, so this thing I'll bring up and this thing over here I'll bring down. So what I would have is 1 over, alright, this is plus 1, so I'll just put over 1 minus st, okay, equals to z. Alright, okay, and then since we know that s can be represented by j omega as a frequency, okay, we know that s is supposed to be real plus j omega, the real plus the imaginary, but in this case we just take it lah, okay. I don't know why, but you just sub it as j omega, so I have 1 over 1 minus j omega t is equals to z. Okay, and therefore this definitions that I've just derived comes all over here in your PPT presentation slides. Okay, so which is in your slides over here. Okay, so I'll just continue from here. Alright, so therefore let's continue. Okay, so in order to write in terms of this thing, eventually your end in mind is this thing, or your unit circle is over here. While when you plot all your, in for example this is the s domain, this is the z domain, or when you plot all your s information all over here from the left half plane, when we plot over here, alright, you'll have something like this. Alright, all of the left half plane, alright, can be converged into within this z domain circle. Alright, but however this raises a question. It's like you're somewhat wasting the why, if let's say you plot everything all over here within this thing, okay, what about the spaces all over here? How can we determine that these are all stable? Alright, this thing is stable. Alright, these are all stable because in the z domain these are all stable. But however, in the s domain they are not stable, because when for some information they may be plotted inside here and may be unstable. Okay, unstable in the s domain but stable in the z domain. Alright, so there is some flaws within this backward system, but we're gonna prove to you that at the end of the day you have a unit circle of this thing over here. This is half, you see. Okay, so somewhat I'll just briefly go through because yeah, it's not, yeah, just for your info only lah. So half minus half will be equals to 0, right? So if you were to cancel this away, you'll get back your particular stuff over here. Alright, so this is one way to actually rearrange your equation into this one first. Okay, and then over here you can combine. When you combine, it becomes this one. Okay, so this thing over here is equals to this thing. Alright, so half I'll leave it over here, while this thing over here I rearrange, I have this. I'll not go through with you how to rearrange, you can do it yourself if you really want to do it. Okay, so I'll just leave it with the bracket. Okay, and next, alright, I rearrange these things. I have this thing over here. Okay, and then after which, alright, this is, maybe I should hold on. So I'll just simply bring this downwards lah, because I want to rearrange some things. Okay, so this is z is equals to this one. Alright, we have proved to you earlier, which is where, over here lah. Okay, so I'll just simply continue over here. So this is also z, this is also equals to z. So now I have this z is equals, so I'll bring this half to the other side. So I have z minus half is equals to minus, is equals to this things lah. Okay, so I'll just crop it out. Alright, I'll just bring it over here. Okay, alright, now which is this step lah. Okay, it's the same thing. Okay, this is 1. If you happen that you don't know what the hell is this is 1. Okay, this is 1. Alright, so half over here is half times these things. Okay, so in case you don't know, so over here, alright, I'll factorize out my minus half. I'll have 1 plus tj omega over 1 minus tj omega. This thing over here is this thing, and minus half is over here. Okay, hope that this is pretty clear. The steps are pretty straightforward. Alright, now I'm gonna bring this all the way upwards. So now we can, alright, so now we're gonna take the absolute value of both of them. Alright, so I'll just take the absolute value which is shown over here. Okay, if such of the case that happens, alright, absolute value means what? This is 1 plus 1 j omega, right? If you add absolute value over here, this is simply become plus. Alright, because absolute is just positive. So this thing over here will become positive also. So if this case that happens, they will cancel each other. Alright, and therefore we will left only with minus. Wait, I hold on a while. I don't think this explanation is very good. But anyway, I'll use this explanation then. Okay, because in order for this to be unstable, alright, the absolute to be unstable, okay, half minus half will be equals to 0. Alright, then things will be unstable, right? Yeah, is it? Okay, anyway, in any of the case, alright, if it happen that if this is plus, this will cancel each other because this is absolute of minus half, this will becomes half. Okay, so in this case, this is minus, alright, but that's why, I don't know, alright. But in the end of the day, we will get half lah, if you were to absolute. I don't want to waste any more time. Okay, so this is half. I'll leave you to think about it. Alright, but in the end of the day, this half over here is at this point. Okay, is at this point. Okay, and then the rest of the z domain, if you were to just plot it lah. Okay, over here, if you were to just plot it, you'll plot a unit circle. Okay, I'll not go through if you how to plot because this is quite tedious. So for all of the left half plane, whatever thing will be all plotted within this particular circle over here. Okay, so I hope this is pretty clear, although not very clear still for this part. But anyway, so let's continue with the trapezoidal one. So we have proved to you that the backward method is okay, it's within this thing, but it's not, doesn't help us because this thing over here, this region over here, alright, is stable for the z domain, but can be unstable in the s domain. It can be within the right half plane because all the left half plane is within here already. So definitely the rest over this side is in the right half plane, which is unstable. Okay, so therefore this is the thing. Okay, so therefore let's go to trapezoidal rule lah. Alright, the last one, very easy. You just change your s is equals to j omega, and then you take the magnitude of them. Alright, so I'll just copy. So if you take the magnitude of this thing, alright, this thing will become plus. Alright, so if you have to cancel them each other, you have only 2 over t. Alright, actually the guy skip steps. Alright, it shouldn't be this way. So actually it's not that easy after all. Okay, anyway, so let's continue with deriving this one. Okay, you may have, okay, before I waste your time, alright, just let you know that in the end of the day, this left half plane over here will be plotted inside this unit circle in the z domain. Okay, if you want to continue to hear how to derive this one, you just continue. If not, I think you just skip lah, because I don't think it may be within the syllabus. But anyway, because these things can still be derived because it's inside your PPT, so I don't know whether if you want to hear, you just hear lah. Okay, so let's just continue chop. Anyway, the problem with this trapezoidal rule, although it can map all the left half plane S into this thing, there is still something that will cause this to be unstable. So you have to be very careful. So in the next video we'll talk about it, but still, before I go to the next video, I'll just derive this thing in case that you forget, in case that you want to chop finish and you just skip this video. So yeah, where should I start? Multiply the 2 inside them, so I have 2 times z minus 2. Okay, and I have t times z, I'll have tz plus z. Okay, now, no, what the hell am I doing? T times z is tz, but t times 1 is actually t. What the hell am I doing? Right, so after a while I realized that I'm wrong. Ta-da! But anyway, let's continue. Alright, So I'll just bring, instead of doing just now that step, which is this one, I'll just bring this, this is 2 over t times this one, right? So I'll just bring this t upwards and then bring this 2 downwards. So what I will have is t over 2 times s is equals to your this thing over here. Okay, I think we are clear. Alright, so therefore now I'll just bring this z plus 1 upwards again. So I'll have this thing over here, t over 2 times s times z plus 1 is equals to your z minus 1 over here. Okay, and then I expand, I'll multiply inside, I will have this thing over here, and this thing over here brings it down. Okay, next, alright, I'll just bring your t over, okay, I'll just bring the minus 1 over this side. So I'll have t over 2s plus 1. I'll bring this thing over to the other side, so I'll have minus t over 2s z over here. Okay, so I'll just simply switching sides lah. Take a while to read. Alright, so okay already. So next, alright, I'll just factorize out my z as a common term, right? So I'll just factorize out, I'll have this thing. Well, I keep this thing the same over here. I bring over here. Next, alright, this z, I keep it, I'll bring this thing all the way down. Okay, so I have this thing over here. This t over 2s plus 1, I just switch sides, so I just bring this one, I bring it over here. This t over 2s, I put it over here. So instead of writing t over 2s plus 1, I write as 1 plus t over 2s. Okay, so I just put it over here lah. Okay, in case that you wonder what the hell is going on over here. But anyway, so this thing over here divided by this thing, when you bring it down, you have this thing. Now, if you were to magnitude it, because I should have magnitude it now. Okay, yeah. So if I were to magnitude this one now, okay, after I bring this down, I bring this down. I think you get what I mean, this fraction now, okay? I magnitude this, so this one will become plus, alright, so everything will cancel each other. So this thing will cancel each other, so there becomes, this whole thing will cancel each other, there becomes equals to 1. Alright, so this is in fact z equals to 1. Okay, and this is the unit circle of 1. Okay, I hope that this is pretty clear now. This is the proof of the equation. But however, instead, before I go, alright, this magnitude z is equals to half, for example, is saying that all along this thing are all half. Okay, that's all it is, and it's at the midpoint of half also. Okay, where there's some proof to you, I think. In fact, they actually didn't say that the center is equals to half, because this thing over here, z magnitude is equals to half, is actually the circle. It's actually for if you have the circle over here, then you have this axis. The radius from this point is half. Alright, the midpoint circle comes from here. Alright, because in order for this to be 0, z must be equals to half also. So half minus half, which is over here, you have equals to 0 at the origin. Alright, so in order for it to be at the origin, your this point over here should be half. So half minus half will be this point over here. So therefore, something like this. So this equation over here gives you the information that it is the center, while this thing over here gives you information that is the radius of half. Okay, just to say, this is for the backward loop, because I've actually forgot to say, not backward loop but backward formula. While the bilinear, the twisting or the trapezoidal one is this one. Okay, so yeah, I still find a bit weird because the explanation for this one is not that good yet. Alright, this z minus half tells you the center that is equals to half, right? It's because if your z is equals to half, for example, okay, then you can either be at this point, which is half minus half, which is 0, or if it's absolute value, for example, then it's plus. Alright, so half plus half will be equals to 1, which is at this point. Okay, so if it's z minus half, then if z is equals to half, then it will be at this point. Not this is just this point lah. Okay, while if it's absolute value, alright, half plus half will be equals to 1, which is at this point. So from here you can somewhat determine that it's actually the middle point. which is half. Okay, because this thing is half, this thing is half also. Hope that this is pretty fully clear, because I feel a bit yeah, gay gao. But anyway, so at the end of the day, the overall summary is that for the S domain, okay, when you plot into all the Z domains over here, alright, all the S domain left half plane, when you use your forward Euler's formula, all your poles and zeros in the S domain will be plotted within this region. Okay? While for the backward is plotted within this region, which I keep on focusing on this thing, alright? Then for the tasking one, which is for the trapezoidal one, all your left half plane information will be all plot inside here. Alright, so it's just nice. Okay? So therefore in the Z domain is stable, in the S domain is also stable. Okay? However, there is some problem that I've said earlier and again. So therefore in the next video we'll talk about why is this not stable and what can we do about this. Okay? So see you then.